She didn't wear a flight suit, she wasn't launched into orbit, but her calculations were the reason others made it home. One mistake and lives could be lost. She never made one. Katherine Johnson, an African-American mathematician, helped launch the United States into the space age. Her brainpower, not software, shaped the trajectory of history. And before computers were machines, they were people. Human computers, brilliant, driven, methodical minds who calculated spaceflight with chalk, paper, and genius. Katherine Johnson was one of the best. Today, we explore the story of a woman whose contributions helped define modern space exploration. Welcome to the channel. Don't forget to subscribe. It's February 20th, 1962. The Cold War is raging. The US and Soviet Union are locked in a technological standoff. Rockets are the new weapons, and space is the ultimate battleground. John Glenn, a Marine Corps pilot and astronaut, is strapped into a Mercury capsule named Friendship 7. He's about to become the first American to orbit the Earth. The mission has taken years of planning and endless calculations. One set of numbers stands between success and failure, and one woman is trusted above all to verify them. Katherine Johnson is in NASA's control center, a dimly lit room buzzing with tension. On her desk, a slide rule, a pencil, a stack of math books. Computers have generated the trajectory data, but Glenn isn't satisfied. He wants the girl to check it. That girl is Katherine. She recalculates everything by hand. If her numbers match, Glenn will fly. They do. As the telemetry data flows in from space, Katherine makes real-time adjustments, refining equations that predict exactly where Glenn will re-enter Earth's atmosphere. It's a high-wire act with no room for error. But Katherine delivers. Glenn orbits the Earth 3 times and returns safely. Her math was flawless, but her name wasn't known. So who was Katherine Johnson? She was born in 1918 in White Sulphur Springs, West Virginia. The youngest of 4 children and the only girl, she displayed a love of learning from the start. At age 4, she could solve arithmetic problems beyond the ability of most adults. Her mind was constantly in motion, always calculating. In classrooms, she was often bored. Her teachers gave her extra assignments just to keep her busy. She didn't just complete them, she devoured them. By 10, she was in high school. By 18, she had graduated from West Virginia State College with a degree in mathematics and a minor in physics. After college, she returned home and began teaching math at a high school. But Katherine had bigger dreams. In 1943, during World War II, she took a leap that would define her legacy. She joined the National Advisory Committee for Aeronautics, NACA, the predecessor to NASA. At a time when the United States was still deeply segregated, this was no small achievement. Katherine, a black woman in a white male-dominated world, was hired as a human computer. Human computers performed calculations before machines existed. They were the living processors behind engineering and science. They used nothing but pencil, paper, and their own minds to compute complex flight data, wind tunnel results, and more. At NACA, the workplace was divided by race. Katherine worked in the West Area Computers, an all-black, all-female unit. They were given their own office, their own cafeteria, and were excluded from meetings. Still, Katherine stood out. Her talents couldn't be ignored. In 1953, she was transferred out of the segregated pool to work directly with engineers in the Flight Research Division. This was almost unheard of. She was one of the few black professionals to make that leap. Her first major assignment came from the Air Force. She was asked to calculate the trajectory for a test aircraft. The work was dangerous. If she got the math wrong, the pilot could die. But Katherine didn't flinch. She worked for months on equations that predicted the plane's path through varying layers of the atmosphere. Her math held. The plane flew. Her reputation soared. Then came the space program. In the late 1950s, NACA transitioned into NASA. America was racing to catch up with the Soviet Union after the successful launch of Sputnik. Project Mercury was born, NASA's first attempt to put astronauts in space. Katherine was brought in to calculate launch windows, orbital paths, and re-entry angles. The lives of astronauts depended on her numbers, and Katherine understood the stakes. She worked long hours, skipped breaks, and often stayed late to run simulations by hand. When Alan Shepard became the first American in space in 1961, Katherine's math helped guide his trajectory. She had calculated the arc of his brief, suborbital flight with precision. But John Glenn's 1962 mission required more than precision. It required trust. NASA had begun using early electronic computers, but no one fully trusted them. Glenn made his position clear. He wouldn't fly unless Katherine had checked the machine's numbers. So she did. Glenn's successful orbit marked a turning point in the space race, and Katherine Johnson had been instrumental in making it happen. Over the next 2 decades, she contributed to nearly every major space mission. She worked on the Apollo program, helping map the path to the moon. Her work was essential in planning the exact trajectory that would take astronauts from Earth into lunar orbit and back again. When Apollo 13 suffered a catastrophic explosion in space, Katherine's prior work on contingency trajectories helped the team develop a safe return plan. She later contributed to the Space Shuttle program and helped lay the foundation for the International Space Station. But through it all, she faced the burden of invisibility. Many of her papers went uncredited. She wasn't always invited to meetings. And although her work was critical, she was often overshadowed by the engineers she supported. Yet Katherine Johnson never stopped. In 1986, after 35 years of service, she retired. But her legacy didn't. She became a role model and mentor, advocating for education, especially in STEM fields. She inspired countless students and championed opportunities for women and minorities in science. In 2015, at age 97, Katherine Johnson was awarded the Presidential Medal of Freedom by President Barack Obama. The citation honored her exceptional contributions to the space program and her role as a pioneer for equality. 1 year later, the book Hidden Figures was released, followed by the acclaimed film adaptation. Millions of people were finally introduced to the untold stories of Black women at NASA. Katherine Johnson passed away in 2020 at the age of 101. She lived through segregation, the civil rights movement, and a century of scientific revolutions. She helped put men on the moon and helped tear down racial and gender barriers. Today, her name is spoken alongside the greatest scientists in history. She has schools named after her, buildings dedicated to her, and a permanent place in the story of space exploration. Her journey reminds us that genius can come from anywhere, that perseverance matters more than privilege, and that even from behind a desk, one woman can help change the course of human history. Katherine Johnson didn't just calculate trajectories, she launched possibilities. If her story moved you, share your thoughts in the comments. What inspired you most about Katherine's life? And if you want to learn more about the unsung heroes of science and space, don't forget to like, subscribe, and explore our other videos. Thanks for watching, and remember, the sky is not the limit.
Godspeed, John Glenn.
John Glenn made her famous because he didn't trust the IBM computers that were calculating the orbits for his first travel in 1962. He wanted them to get the girl to do those hand calculations, and that girl was Katherine.
Katherine Johnson actually came to NASA before they were computers as we know them today, so we actually needed humans to do all those mathematical calculations. At that time, the computers were segregated, so there were white women computers and there were African American women computers. So even though they were doing the same work, the same complex mathematics, they were actually separated. But Katherine was so talented. Katherine was quickly elevated because she was so good at what she did.
She came to work, ready to work. Although people might have been concerned about whether or not women, and especially black women, could contribute to NASA's mission for the nation.